The deformation. What is deformation? So deformation is a transformation from initial to final geometry. That means if any body is under stress condition, if we apply force to a body, then its shape size will change, or the particle or molecule within the body will change. So deformation means like that if a completely object that will move from one place to another place, or it will rotate, or its volume will change, all will be considered as a deformation. So deformation, that's why it is a transformation from an initial to final geometry. Suppose this is a object. So if you apply force on it, then its shape will change depending upon what type of force we are applying. So suppose this type it will change like this. So now this is its initial geometry and this is the final geometry. So that is called as a deformation. Simple. ये गोटे shape रो आगोटे shape पे जाओ through different process. So that is called as your deformation. So you can see like this, a body can change position by rotation. It can change position by translation, or it can change position by shear. So all can be considered as your deformation. So it is a rotation, it is translation by the particle of the object. They will move in a circular path. Here they will move parallel to each other. There is translation, or there will be shear. There can be two types: simple shear or pure shear. We'll discuss in the next section. We have so these are different type of deformation. So simple logic, the geometry will change, or it will displace from one place to another place. Depends more about a linear object मतलब folded है, that is a deformation. गोटे object मतलब break होची, fold होची, that is a fault होची, that is a deformation. Foliation by lineation कोचो को object stretch है जाउची, linear होची, planar होची, all are comes under deformation. देखिए हमें what are the different components of deformation? The three components of deformation: what translation, what rotation, and strain. Either object will rotate, it will translate, or there will be a change in geometry, or you can say there will be resultant geometry. So what is translation? It is like translation in crystallography one place to translate how. The translation of move of every particle in the rock in the same direction and the same distance, and the displacement field consists of parallel vectors. Suppose it consists of these particles. So it is saying in translation, moves every particle in the rock in the same direction. They will move in same direction. All will move in the same direction and same amount. What direction is same amount, so particle move करे. That will be translation. Suppose a object आछि, एटी की move करूँ, a place को move करूँ. For each particle, you consider करियो. All particles they are moving in the same direction. Same direction है नहीं. Any particle you take, they will move in the same direction. So that is usually translation. And amount will be same. How? Because this particle is moving to this point. The distance between these 2 points will be similar as the distance between these 2 points also. So the translation is same direction and same amount. You can take the example of faulting. In fault, what happens? One block slide flash with respect to another block. That is the translation mechanism, where one block is moving over another block. So they are moving in a particular direction, and each block is moving in the same direction. If they are not moving in the same direction or same amount, it will be a rotation. So that will be a type of fault, what we call hinge fault. ଯଦି ସେଟା ନ ହଉଛି ତାହେଲେ କ'ଣ ହବ? ରୋଟେସନ ହେଇଯିବ, hinge fault ହେଇଯିବ. That is a rotation which is taken when particle will move in a circular path. That is which is rotation. Then comes to strain. Strain or distortion. Like a deformation. Normally it is the resultant of stress. Way shape change. Any change in shape with or without change in volume is called as your strain. If the volume change involved, it is called as your dilation. Volume change involved is dilation. If the volume change is strain. The strain is distortion, non-rigid deformation, relatively simple to define. Any change in shape with or without change in volume is referred to as strain. Suppose this is a rock body. Now it is deforming. It is like this. Now the shape is changed, but the total entire volume will be same. R jaha volume ho, R say volume. But volume change means, suppose a rock body is like this, then it shrinks to this shape. So here the shape remain constant, but the volume changes. So it is usually dilation. Sometimes it is considered as volumetric strain. So these are different components of deformation. Then deformation can be of two types. Can define them. We can define the deformation into two types. One is homogeneous deformation, another is heterogeneous deformation. Homogeneous, heterogeneous. In homogeneous deformation, the rock volume will be identical throughout the volume. The deformation for the parallel line remain parallel. That is called your homogeneous deformation. So this thing is deforming this shape. You will draw parallel line like this, and after deformation that also remain parallel like this. So it is homogeneous deformation. Straight line will remain straight, parallel line will remain parallel. So it is straight line for straight action after deformation, parallel line for parallel motion after deformation. So it is called as a homogeneous deformation. So it is any type of deformation will take like this. Parallel line will remain parallel, straight line will remain straight. So in heterogeneous deformation, if you take a rock body like this, it will deform in a irregular shape. It will deform to a very irregular shape where the line will bend like this. It will be a heterogeneous deformation where the stream, volume, area all will change. It is just in case of heterogeneous all will remain same. In case of in case of homogeneous all will remain same. In case of heterogeneous all will change. Then come to stress. So what is stress? Force by area. Pressure is also force by area. So the term pressure is generally limited to the medium with no or very low shear resistance. That means suppose we are applying stress to a rock body. We apply stress to a rock body on the rock surface. Then this is the normal stress, and this is the shear stress. Pressure is only considered where the shear stress is zero. Okay. So pressure is also force by area. Stress is also force by area. Pressure we consider when the shear stress is very limited or zero, but in case of stress, there should be some shear resistance. Kisile shear resistance diba darkar. So that is the difference between pressure and stress. Otherwise, the definition will be same. Pressure is also force per unit area. The unit of stress, it is the SI unit of Pascal. 1 Pascal equal to 1 Newton by meter square. Newton mass per Newton force equal to mass into acceleration. Mass is kg. Acceleration meter per second square. This is by meter square. It will be 1 kg per meter into second square. So 1 Pascal, it is 1 kg per meter into second square. 1 bar equal to 10 to the 5 Pascal. An important thing in PA, capital M is for million. This is called as megapascal. 1 megapascal equal to 10 to the power 6 Pascal. 1 megapascal is equal to 10 to the power 6 Pascal. Or 1 gigapascal is equal to 10 to the power 9 Pascal. Also, stress can be of two types: normal stress and shear stress. So, any stress applied on a rock body to a plane inclinedly, a plane को inclinedly वो stress apply करे, it will resolve into three components. So, हम normally force पर कौन सी where incline कौन सी thing को apply करे, it will resolve into two components. Here, in case of stress, when you apply inclinedly to a plane, it will divide into, or it will resolve into three components. One is normal stress, another two is shear stress. The normal stress that oriented perpendicular to the surface, that is called normal stress. In shear stress that acts parallel to the surface, that is called as shear stress. You can see here where stress is applied perpendicularly to the area, to the surface, it is normal stress. Or if it is applied parallel to the layer like this, it is shear stress. When it comes to stress on a surface, if you apply stress on a surface, it is simple. You are applying stress like this, so it will be simple force by area. Apply stress, then with time, with more force or stress, it can break or develop fracture. Fracture develop. So important thing, see, tomorrow stress at a point. So if you think, suppose this is a rock body, stress is applied on all direction, from all the three direction. Then you just think a small point within the rock. पूरा सबठु छोट पॉइंट रॉक होते ता ऊपर जाई स्ट्रेस टा पड़ुथबो ना. So that we call the stress at a point or stress at a very small cube within the rock body. So if you apply stress on a point, then it will resolve into different components. Like suppose it is more stress apply hela, in the direction of stress apply hochi. If all the stress are perpendicular, there will be no shear stress. If stress to perpendicular act hochi, then shear stress kichi asiba nahi. But if stress is applied obliquely to the plane, then all will resolve into components. So we are applying stress in all directions. From direction stress apply करछन. From this direction, and from this direction. So top, front or side. तीनटा condition तमिले. Top side रो पड़ुछि, front side रो पड़ुछि, और side रो पड़ुछि. So each force will resolve into three components. So force रा कौन? तीनटा component रे resolve होगा. One sigma 1, sigma 2 and sigma 3. Each will resolve into three components. So total there will be 9 components. So we will consider this as x direction, this is y direction, this is z direction. So along x direction we will have sigma x, sigma y, sigma z. These are called as principal stress axis or principal stress because they are perpendicular to the plane. So those stress they are perpendicular to the plane are called as principal. In case where the shear is 0. So now we can say these are normal stress. Normal stress. So sigma x, sigma y, sigma z. Those are not perpendicular to the stress. Then shear stress. The shear stress here it will be like this. One in this side and this also has the opposite in this direction. So it will be resolved like this. You have shear stress is symbolized as tau x, tau xy, tau xz, tau yx, yz, zx, zy. So tau xy, then tau yx, they will cancel each other. Tau xz, tau xz, zx, it will cancel each other. Then yx, so zy, yz, they will cancel each other. So that means because all the shear stress they are equal and opposite to each other, so they will cancel the effect. So all the stresses, shear stress will be equal. Like tau xy is equal to tau yx. Tau xz equal to tau zy. Tau yz equal to tau zy. So that means they are not equal and opposite. So by this we have 3 shear stress, 3 normal stress. If all the shear stress have a 0 value, then the normal stress are called as principal stress. Suppose so the force apply hochi for this sigma z and these two value as 0, there is no shear stress in the rock, then sigma j is considered as principal stress axis. इसमें हमें sigma 1, sigma 2, sigma 3 नहीं की called to define करते there is no shear thing. So you can see shearing नहीं. There is also hydrostatic stress and deviatory stress. So hydrostatic stress, what is hydrostatic stress? If stress, so sigma 1, sigma 2, sigma 3, it is equally applied from all directions. Suppose it is a rock here. I am applying force 5 Pascal, 5 Pascal, then 5 Pascal from all directions. Then it will be a hydrostatic stress. If stress is applied equally from all directions, it is called as a hydrostatic stress. So in case of hydrostatic stress, the shear stress is 0. Because जेहेतु हमारा जियोलॉजी रे हमें सबरे hydrostatic stress ऊपर ही deal करते like मोरा lithostatic stress. It is also a kind of hydrostatic stress by uniform stress हम कहते हैं, है ना? जाते हम सबरे shear stress 0 consider करते हैं. यदि stress component system unequal था amount, ताले तब क्या है deviatory stress. इसको लाजो deviatory stress या तुम्हें non uniform stress पे करें. बा डायरेक्टेड स्ट्रेस पे करियो गोटे डायरेक्शन अधिक पड़तो गोटे डायरेक्शन ने कम पड़तो जेते पर्यंत तुम्हारा डिविएटरी स्ट्रेस न हेची सेते पर्यंत कोन गोटे ऑब्जेक्ट ब्रेक करिवो ना से सबे वॉल्यूम चेंज होता प्रिंसिपल स्ट्रेसेस मैं कहली प्रिंसिपल स्ट्रेसेस जोटा नॉर्मल स्ट्रेस ऑन प्लेन वेयर शियर स्ट्रेस इज 0 सो वी रिप्रेजेंट थ्री प्रिंसिपल स्ट्रेसेस सिग्मा 1 सिग्मा 2 सिग्मा 3. Sigma 1 is always maximum or major principal stress axis by stress पे करियो. In case of ellipsoid, we will call it as stress axis. Here it is simple called as stress. Maximum by greatest principal stress axis. Then sigma 3 is minimum and sigma 2 is intermediate. If this represent in ellipsoid, it is called as a stress ellipsoid. देखो तुम्हें ellipsoid represent करियो जो वाला तेवा represent करथिले in case of stress fault पे पड़तो एमितर represent करछन्ती that this is sigma 1, this is sigma 3, this is sigma 2, this is called as stress ellipsoid where we represent principal stress axis where the normal stress value is 0. Sorry, normal stress value and shear in case of tomorrow force applied on a plane where normal stress value will be either sigma 1 or sigma 2 sigma 3 and the shear stress value will be 0. So in that case it is called as your principal stress. So simple force acting on a plane with 0 shear stress can be called as a principal stress.